Hello everyone, I am Dr.VRAO-PHYSICAL. From the lecture 55 of thermodynamics, we came to know that thermodynamics is based on three generalizations, usually we called as laws of thermodynamics. Those are you never get something for nothing. First generalization is you never get something for nothing. And the second one is you never get more than you pay for. Usually you get less, right? You never get more than you pay for and usually you get less. And the third generalization is perfection is unattainable. Perfection is unattainable. So these are the three generalizations which we called as laws of thermodynamics, and these generalizations have what is it called equation forms that we discussed. We will discuss that three laws of thermodynamics in the coming classes. And moreover, we came to know that thermodynamics deals with heat changes or energy changes accompanying a process in which matter is considered in bulk. And moreover, we have had gone through the terminology of thermodynamics, that is system, surroundings, types of systems, extensive properties, intensive properties, state functions and path functions. Of all thermodynamics, there are two path functions. Those are work and heat. Those are work and heat. Work and heat. These two are these two are path functions. Okay, that means in the entire thermodynamics, path functions are only two. Okay, these are work and heat, right? So let us know more about these path functions, right? Let us know about heat and work one by one, right? So first one is heat. Heat, usually it is represented by Q. It is represented by a letter Q, okay, Q, small q, and in sometimes we represent it with a capital Q, right? Okay, Q. So heat is a form of energy. Heat is a form of energy and it transfers from one system to another system because of temperature difference, right? Heat is a form of energy which flows from one system to another system due to because of temperature difference. And during the heat flow there is energy transfer also takes place. That is, during the heat transfer, energy transfer also takes place. That is, energy changes also takes place, right? And heat transfers occurs through reheat. You should keep this point in your mind. Heat transfer occurs through a conducting wall between the system and surroundings, which constitute the boundary between system and surroundings, right? Heat transfers through a conducting wall which constitute a boundary between system and surroundings. So conducting walls, so there are two types of walls. There are two types of walls. There are two types of walls. Actually, this wall is between system and surroundings. Okay, there are two types of walls, that is diathermic wall, diathermic wall, diathermic wall, and adiabatic wall, adiabatic wall, right? So heat transfer or heat occurs through a conducting wall which constitute boundary between system and surroundings. Okay, therefore walls are two types, diathermic wall and adiabatic wall. And this diathermic wall means this diathermic wall allows heat transfer or allows heat flow, allows heat transfer. That's why a diathermic wall is called as conducting wall. Diathermic wall is called as conducting wall. And adiabatic wall, this adiabatic wall does not allow heat transfer between system and surroundings. Therefore, adiabatic wall is called non-conducting wall. Non-conducting wall. So, these walls constitutes a boundary between system and surroundings. Okay, if there is diathermic wall, there is that is conducting wall, that there occurs heat transfer between system and surroundings. If there is adiabatic wall, adiabatic wall does not allows heat transfer between system and surroundings. And we need to know the sign convention for heat. When heat is absorbed by the system, we assign a positive sign to Q, right? If heat is absorbed by the system, then we assign a positive sign for Q. Okay, heat absorbed. If system absorbs heat, that is heat absorbed, then we assigned positive sign for Q, right? And if heat is evolved from this system or heat is lost by this system, then we assign negative sign for the Q. That is heat absorbed, we assign a positive sign, that is heat absorbed, that is energy restored, that is that we are giving energy. So, that is for that we assign a positive sign. And heat evolved, that is system lost its heat energy, that is system losing its energy, that is then in such case we assign a negative sign for that. So, this is one path function, right? And let us see another path function, that is work. Work, which is represented by W, right? Work is a it is a form of 1 minute. Okay, work is a mode of energy transfer between system and surroundings. Work is a mode of energy transfer between system and surroundings, right? We have a conventional definition for work. We have a conventional definition for, from the lower classes to up to this time, we have a conventional definition for work. Work is equal to, that is work is force into displacement. Work is a product of force into product of force and displacement, right? That is F, S, that is F and S, force and S, right? So, we have this conventional definition, that is if we apply a certain force F, or if we apply F amount of force on a object which is in static position, then by applying that F amount of force, that object displaces from its position. That means in such case we call that work is done, right? You know very well about this definition. Okay, so work is a force into displacement, but here this force is called as a intensity factor. This force is called as intensity factor, and this displacement is called capacity factor. This displacement is called capacity factor. So, based on the intensity factor and capacity factor, this work can be called with different names, right? Based on the intensity factor and capacity factor, we can call that work with different names. Okay, for example, gravitational work. For example, gravitational work. Gravitational work. In this gravitational work, intensity factor is mass into gravity, and capacity factor is height that is moving, okay, that is mgh, where h is capacity factor, that is which undergoes change, okay, which undergoes change or which undergoes h, that is height that moves, right? So gravitational work. And coming to the electrical work, and another work, that is electrical work. In this electrical work, intensity factor is coulombs, that is charge into potential difference or potential gradient. Potential gradient is capacity factor, and q is intensity factor is charge. Okay, and in case of what is it called, mechanical work, in case of mechanical work, okay, mechanical work, intensity factor is pressure, and capacity factor here is, that is the element that undergoes the, or the quantity that undergoes changes is volume, that is volume undergoes changes, right? So this is in this mechanical work, intensity factor is pressure, P, external pressure, right? External pressure, and delta V is capacity factor, that is volume undergoes change. Okay, volume undergoes change. Right. So this mechanical work is very important in entire thermodynamics, because in thermodynamics, work means that is a mechanical work. Work means that is a mechanical work. Energy means that is heat energy. Okay. You keep these 2 points in your mind. Energy means, in entire thermodynamics, energy means that energy is heat energy. Work means that is a mechanical work. Work means that is a mechanical work. That is that work also called as a pressure volume work. Pressure volume work. So pressure volume work is also called as mechanical work, right? So this is the mechanical work. Okay, and coming to the sign convention for this path function is work. If work done by the system, then we can, that is work done by the system means it is a mode of energy transfer. Already I told you work is a mode of energy transfer, that is work done by the system, that is system does some work, that is system losses its energy. That is, if work done by the system, then we assign negative sign for that work, right? So work done by the system, then we assign negative sign for that work. That is, already I told you, you please remember this point. Work is mode of energy transfer, that is work done by the system means system losses some energy. So that's why we assign a negative sign for work. So work done by the system, we assign a negative sign, and work on the system, that is in such case we assign a positive sign for work. Okay, so we assign a positive sign if work done on the system, right? Okay, we let us know more about the work after a while. Before that, we need to understand that reversible process and irreversible process, reversible process and irreversible process. Okay. So we need to understand reversible process and irreversible process. Reversible process. Reversible process. Right? Okay. A process which is carried out infinitesimally slowly, so that driving force is infinitesimally greater than opposing force is called reversible process, and reversible process it can be reversed at any instant. I repeat, a process which is carried out infinitesimally slowly so that driving force is infinitesimally greater than opposing force, and that process can be reversed at any instant. That process is called reversible process, right? And we can understand with a diagram, right? We will understand with a diagram, right? And irreversible process, irreversible process. Irreversible process, a process which does not carried out infinitesimally slowly and it cannot be reversed at any instant. That process is called irreversible process. How can we understand this reversible process and irreversible process? Because in entire thermodynamics we always use the terms reversible process and irreversible process, expansion, compression. Okay, so work done on the system, work done by the system, right? So we have to get aware of these two terms. Okay, to understand these two terms, we need a diagram, right? That is, let us consider a what is it called? Piston. What is that? Weightless, frictionless piston in which gas is enclosed, right? So let us consider weightless, frictionless piston in which gas is enclosed, in which gas is enclosed. Let us see the diagram. Right, okay. So let us consider this a weightless piston, weightless frictionless piston in which gas is enclosed. So that is, we assume that gas is enclosed in this piston, right? So the pressure of the gas within the piston, we label that pressure as P, pressure of the gas, pressure of the gas. And the pressure on the piston, the pressure on the piston, that is labeled as external system. Pressure on the piston, that we label that pressure as external pressure, P external, P pressure external, right? So there are two pressures, the pressure on the piston and pressure of the gas within. Okay, pressure of the gas within, right? Okay, so let us assume the pressure of the gas within and the pressure on the piston, that is P external, are equal, right? That is, let us assume pressure on the piston, that is P external, is equal to pressure of the gas within the piston. So in this case, these two are equal. In such case, piston neither move upward or downward. Piston neither move upward or downward. Okay, that is, piston does not move upward or downward. So in such case, work done is zero. Work done is zero. That is, work done zero. How can I say that work done is zero? Here the capacity factor, that is the parameter or the quantity which undergoes changes, is zero. Here the pressure does not undergo any expansion or compression, and that is, piston does not move upward or downward. Okay, so capacity factor is zero. But intensity factor, because intensity factor is P external and capacity factor, there is no change in capacity factor. So there is no, in such case, work done is zero. Okay, and coming to the second case, this is the case 1, and this is the case 2, in which pressure of the gas, and this is the P external pressure, pressure on the piston is P external, and pressure on the piston, that is P external pressure decreased infinitesimal, and the infinitesimal pressure is decreased on the system, that is P external pressure on the piston is decreased infinitesimally, that is external pressure is decreased by infinitesimal amount. External pressure is decreased by infinitesimal amount, right? So that is P external pressure decreased infinitesimal amount. Infinitesimal amount, that is very little amount. Infinitesimal amount means that is very little amount decreased. We assume that P external pressure is decreased infinitesimally, and pressure within the gas is P gas. Okay, so therefore pressure of the gas within the piston is more than pressure on the system, that is P external pressure is infinitesimally less. Okay, infinitesimally less than pressure within the gas. Okay, in such case, that is pressure within the gas, we call that pressure of the gas is driving force. Okay, driving force. In this case, driving force is infinitesimally greater than opposing force, where if the gas wants to expand, that what is the opposing force? External pressure is the only opposing force. Okay, so we assume that the external pressure, that is opposing force is assumed to be decreased infinitesimally, so that this piston undergoes or this piston move upward, right? That piston move upward. In such case, work is done by the system. So here gas undergoes expansion, that is when gas expands, piston moves upward. You can see that movement of the piston with dotted lines. Okay, so when the piston moves upward, there is a change in volume. Of the gas, that is capacity factor changes. So in such case, work is done by the system. But we decreased the external pressure by infinitesimal amount. Okay, infinitesimal amount. We are decreasing the external pressure by infinitesimal amount. So this process can be reversed at any instant. This process is called, in this process, the driving force is infinitesimally greater than opposing force, and the process can be reversed at any instant. So such process is called reversible process. Right? So this is the reversible process. Right, because this piston expands very slowly, infinitesimally slowly, so that we can reverse the process at any instant, provided if the external pressure is infinitesimally smaller than driving force. It is possible only when driving force is infinitesimally greater than opposing force, right? And we can revert the piston at any instant. This process is reversible process. So in this case, work done by the system because of capacity factor changes, right? And the third case 3 is, in this case we assume that P external, the pressure, external pressure is and the pressure of the gas, this is the pressure of the gas, and P external pressure, if we assume that P external pressure is less than pressure of the gas, less than pressure of the gas, that is driving force is more than opposing force. But here driving force is infinitesimally greater, driving force is infinitesimally greater, but here driving force is higher than, more than opposing force. In such case piston moves rapidly, piston moves rapidly with the piston moves rapidly, not infinitesimal movement, not infinitesimal movement of piston, not infinitesimal change in capacity factor. Infinitesimal capacity factor changes rapidly, that is piston moves rapidly because the external pressure is very less than driving force. Okay, external force is less, very less than driving force. Okay, in this case also work done by the system, but this process cannot be reverted because external pressure is very less than driving force. So we cannot revert the piston movement, that is we cannot reverse the process at any instant, So this is a irreversible process. Okay, so this is the reversible process where the driving force is infinitesimally greater than opposing force. This is the irreversible process where the driving force is more than opposing force. Okay, so this is the irreversible force, and this process can be reversible at any instant. This process cannot be reversible at any instant, right? So reversible process and irreversible process, but this is the reversible process, and in this case gas expands. Okay, gas expands. So gas expands, work done by the system, we assign a negative sign. So in this irreversible process also work done by the system, we assign a negative sign for the work. Okay, so because volume capacity factor changes, that then for example if pressure on the piston is more than driving force, that is pressure of the gas, in such case work done on the system, in such case we assign a positive sign, we assign a positive sign. Okay, we assign a positive sign when opposing force is more than driving force, then compression of gas takes place, that is decrease in volume. Of course that in such case also volume changes, that is capacity factor changes, but work done on the system, in such case we assign a positive sign for that work. Okay, and for example, and coming to the irreversible process, if in this reversible process, if the P external pressure is more, external pressure is not less, very less, external pressure is more than pressure of the gas, that is opposing force is more than driving force, in such case gas undergoes compression, in such case we assign a positive sign for that work done on the system, that is we assign a positive sign. Okay, but the fact is reversible process is not attainable in practice. Okay, reversible process is reversible process cannot be realized in practice. Reversible process cannot be realized in practice because it can take a lot of time to takes place, because this piston moves infinitesimally slowly. So reversible process take more time. it take infinite time to complete, but irreversible process it take it takes place very rapidly. It takes place very rapidly. So reversible process cannot be realized in practice. Okay, because it can take it requires a lot of time to completion. It requires a lot of time to complete, right? And that's why, and in most of the process in nature and in chemistry laboratory are irreversible. I repeat, most of the processes in nature and in our chemistry laboratory are irreversible. Therefore, reversible process is remains imaginary and theoretical. Reversible process remains imaginary process. Reversible process is a imaginary process and it is a theoretical process, right? Okay, but what we need to know is in solving the problems, when we are solving the problems in thermodynamics, we need to calculate work done. We need to calculate work done in reversible process, work done in irreversible process, work done isothermal reversible expansion, that is work done due to the expansion of the gas and work done due to the compression of the gas in reversible process, and in irreversible process work done by the gas in irreversible process, work done on the system in irreversible process. Okay, 4. Okay, so there were established equations, there were established formulas for calculating the work. Okay, so if work done by the system, that is expansion of gas, was reversible expansion of gas, reversible expansion of gas, that is isothermal. Okay, usually we made that operation at isothermal, that is at constant temperature. So isothermal reversible expansion, isothermal reversible expansion, the equation that was established for calculating the work is work W is equal to minus nRT ln V2 by V1. Okay, we can simply write this minus 2.303 nRT log V2 by V1, because volume changes. When expansion takes place, volume changes. Okay, and volume and pressure are inversely proportional. So we can write this formula 2.303 nRT log P1 by P2. Okay, this is the formula to calculate isothermal reversible expansion, that is work done by the system. Okay, work done by the system. Okay, for example, work done on the system, how can we calculate? You just revert the sign. Okay, isothermal reversible compression. For isothermal reversible compression, work is W is equal to 2.303 nRT log V2 by V1. You just remove the negative sign, right? So work done, the extent of the work is same, but sign is different, right? So here V2 is final volume, V1 is initial volume. You remember this point. V2 is final volume, V1 is initial volume. In this case, reverse, right? Next, and in irreversible isothermal irreversible expansion of gas, expansion of yes. Okay, so how can we calculate this? There was a established equation or a formula for isothermal irreversible expansion of gas is minus P delta V. P delta V, that is change in volume, because this process carried out irreversible, okay, irreversible, that is these formulas are derived from Carnot cycle, okay. You no need to understand how this formula is established, okay. You need to know this just formula, okay. So W is equal to minus P delta V, minus P delta V, okay, because the process is carried out irreversibly, okay. Volume changes, that is gas expands rapidly in irreversible process, okay. So isothermal irreversible expansion of gas, the formula for calculating the work is W is equal to minus PdV. Or example, isothermal irreversible compression of gas, work done is W is equal to, you just remove that sign, P delta V, okay, P delta V. So delta V is change in volume, you keep this point, delta V is change in volume, right, okay. So here the V in reversible process, V2 is the final volume, V1 is the initial volume. So these are the formulas to calculate the work done in isothermal reversible process, isothermal irreversible process, that is expansion, that is for expansion and compression also. I hope you understand this lecture. If you really like this video, you please extend your support by like, share, comment and subscribe. Thank you for watching.